What's the difference between dark matter and antimatter? Okay, let's talk about antimatter first. Okay, what is antimatter? Antimatter is a very straightforward thing. It's a type of matter that is composed of antiparticles. An antiparticle has the same mass as its regular particle of ordinary matter, but it has the opposite electric charge and it has the opposite quantum properties. So it is not just charged in an opposite manner, positive to negative, but the quantum numbers are also, the quantum properties are also the opposite. And when a particle and its corresponding antiparticle meet, they annihilate. Then they release a tremendous amount of, well, a very properly measurable amount of energy in the process. So, for example, we are familiar with electrons. Yes, electrons, electric shocks. So, electrons have antiparticles called positrons. So, the positron has the same mass as the electron, but instead of a negative charge, it has a positive charge. So that's a positron. That's the antiparticle of the electron. Now we know of protons. Protons are positively charged. They are components of the nuclei, right? So the proton has an antiparticle called the antiproton. So the antiproton has the exact same mass as a proton, but it has a negative charge. The neutron is also a component of the nuclei of various atoms apart from hydrogen. So the neutron, as we know, is a neutrally charged particle. It has no real charge, no charge. Even the neutron has an antiparticle called the antineutron, which once again is electrically neutron, but it has the opposite baryon number. Okay. Then neutrinos have corresponding antineutrinos with opposite lepton numbers. So like I said, when particles and antiparticles come together in the meet, they annihilate each other in a burst of energy, typically photons. And these are typically high energy photons, gamma rays, and it could be also particle antiparticle pairs. So yeah, that's how it goes. And antimatter can be produced in particle colliders like the Large Hadron Collider, particle collisions and accelerators, and also in certain types of radioactive decay spontaneously. And yeah, that's what antimatter is. Now, what is dark matter? Dark matter is nothing, it has nothing to do with antimatter. It is the mysterious 25% or so of the universe that we don't understand. If you look at the total mass energy composition of the universe, we see a lot of stuff out there in the universe, don't we? We see stars, galaxies, nebulas, quasars, pulsars, neutron stars, whatever, all that. You add all of that together, all of that matter together in the universe, that makes up only 4% of the mass of the universe. 4%. That's it. The rest of the universe is unknown. It is dark. We only understand 4% of the universe, and that too, not very well. Okay? So then there is about 25 or so percent roughly, which is dark matter. And the rest, about 70, 71%, maybe 69% is dark energy, which is even more mysterious. I'll not go into that, dark energy, because you didn't ask me about that. So what's dark matter? Dark matter is most likely some kind of particle or particles which interact only gravitationally. Some physicists will say that dark matter can have the weak interaction. Well, for me, that's not dark matter, because we can detect neutrinos. I know that most of them pass through us. There are trillions of solar neutrinos that are passing through my body right now, every second. And they typically don't interact at all with the ordinary matter. But yes, we can still detect neutrinos, which means that they are not dark matter. From my perspective, dark matter has to be purely gravitating matter. Some weird kind of particle that we are not familiar with, or family of particles, or class of particles. So it's quite likely there is dark matter in this room with me. And it may be passing through me right now. And it will interact even more weakly than neutrinos. Way more weakly than neutrinos. Or it is essentially impossible to detect. But we can detect its presence through gravitational lensing and the dark matter halos that are known to exist around galaxies and so on. So it is some kind of matter that we don't know, that we are unable to understand. Probably some kind of particle or particles. Maybe it has something to do with primordial black holes or microscopic black holes, or perhaps bound states, stable bound states of microscopic black holes, quantum bound states perhaps, who knows. So yeah, that's the difference between dark matter and antimatter.